pretend
No. That we like calculus.
pretend you like calculus. You do that every day, right?
I don't pretend.
Okay, what if I asked you to find the arc length of this from 0 to 2 pi? The arc length. Does this sound familiar?
No.
Yes, it does.
Have we done this before?
Yes. I know geometry.
No.
Yeah, we have. What about the circles? Geometry didn't have this on circles.
So we've not found the arc length of functions. How, if you didn't know anything about calculus, how would you at least approximate the distance from here to here? So if this were a string, how could you, I know you could go and you get a ruler and measure it that way. Assuming you can't do that, what's one technique we could use? What do you think, Brett?
Solve for the zeros.
Okay, solve for the zeros. That's a 0 and that's a 0. And that's a 0.
Solve just find the difference between zeros.
You mean that when the derivative is 0?
The equation is zero.
Okay, so the distance between here and here, the linear distance is how far?
Oh, we're trying to find.
It's just pi. So,
I thought
any
you
other-
length of the arc, not the arc length.
oh, I see. Yeah.
We could find a line, like a linear one, from like 0 to where the derivative is 0, and then another line from like there down there.
I
and
like
another
it.
line from there to there.
Good.
Yeah.
So if I, that's at pi over 2, right? How long is that line?
Now we gotta find it.
Okay, so we could use Pythagorean theorem, or we could use the distance formula, right? So that's pi over 2, and that would be,
One.
how tall is that? 1. So the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this case, it's the square root of pi over 2 squared plus 1 squared. So once I get that result, if we're just going to have this, what would I have to multiply it by to get the entire arc length?
2.
4. 4, right? 2, 3, 4. Those are all the same. So it's 4 times all of this stuff. I have 2 markers, the same color. Very effective. Okay, I'm going to change on this one.
Yeah, see that one's right. Slightly
So-
darker.
Jake,
Yes.
you're on this. I want you to figure that out on your calculator. Alright. So we're going to manipulate the
Marker.
We can edit that, can't we? Nope. Alright, so let's say I want to, how can I better approximate? Obviously 4 different increments is not ideal, so what would I do?
Infinite increments.
Right, so if I found a whole bunch of them, infinitesimally small, it would be a better approximation. Okay, so I could do a sum of my formula where x2 minus x1, I'm just going to call it delta x. That's the change in x sub I squared plus delta y sub I squared. So if I added up all the 1 all the way to n, if n became infinity, we would have a better approximation. So this is not an obvious next step, but we're going to change the way delta y sub I looks. We're going to factor out a delta x of x sub I. Do you agree that that is still delta y sub I squared?
Yes.
It's the same thing, right? Okay, now I can factor out a delta x sub I squared. Notation nightmare.
Backwards.
Alright, so if I separate these square roots, which is legal, square root of it, that squared is just itself, right? So I'm going to put that on the outside. And if we're going to send this limit to infinity, it becomes an integral from a to b of the square root. This one went on the outside, and we're going to make it in integral notation dx 1 plus delta y over delta x squared is just dy dx squared. So this is the arc length. Okay, that's how you find arc length. That's the formula you're going to use in this section. So let's do it. Find the arc length of y equals sine x from 0 to 2 pi. So 0 to 2 pi, square root of 1 plus, what's my derivative?
Negative cosine x.
Cosine x. So we have cosine squared x dx. Jake, you got an answer for the other one?
Yes, 7.44.
Thank you. Who wants to tackle this one? By the way, Jake, you're on it. You did so well with the first one. Is our answer going to be less or more than what we got before?
More.
More.
This should be more, right?
Yeah.
Because this is an underestimate in all 4 spots. Are you working on it, Brian? I'm just going by memory. I think it's like 7.6.
7.6439.
Thank you. Okay, so that's how you find the arc length. This looks like it's the surface area. Do you remember the surface area formula? Okay, so this is how you find the surface area of an object. That was in 7.3. This is 7.4. It's the arc. So surface area, I kind of think of it as if I have a cylinder and I wanted to find the surface area of the cylinder, excluding the top and the bottom, how would you find the surface area of this? How do you find the surface area of the cylinder? Tom?
You would find the surface area of the 2 circles and then like the circumference times the height.
Very good. So excluding the top and the bottom, he said the circumference of the top times the height. So if I unroll this, it becomes a rectangle. And this rectangle up on top is 2 pi r. And then the height is this. So the surface area, this would be the height, I think of it as, and 2 pi r would be the circumference. So that's why surface area is a little more complicated than just the arc length. Okay. What's another way we can write this? What do you think? I'm hearing y equals x. True?
Could be absolute value of x.
Well, if x is -4, then y should be -4. Is that true?
No.
It's y equals the absolute value of x.
Good. So absolute value of x. So if I had, what's another way I can write this?
X plus 3 squared.
And then you got to square root it, right? So it'd be y equals the absolute value of x plus 3. So if I was going to rewrite either of these without absolute value, it would take a couple equations, right? Y absolute value of x looks like this. So for when x is less than 0, it's y equals -x. Greater than 0, it's y equals